somewhat treat it like you've never seen it before, just because it's been a while, and a lot of people have a lot of misconceptions about the Pythagorean theorem. They don't understand how it works, so I'm hoping today we'll just solidify that, really make real sense to you. So, first of all, when does the Pythagorean theorem work? I've heard a lot of you throughout the year actually try, like you'll see a triangle, any triangle, and it's not a right triangle, and a lot of you will look at it and say, oh, you just used the Pythagorean theorem. So I've seen a lot of you say, like for example, if I was given a triangle like this, and then you were given two sides like 2 and 4, they're like, oh, well, we can find this side using the Pythagorean theorem. But that's not true. You can't do that. It only works for right triangles. So once again, we only can find missing side lengths by using the Pythagorean theorem if we have a right triangle. So just keep that in mind, okay? Does everybody understand that? Yes or no? Okay. So, once again, what's the Pythagorean theorem used for? It's used to find missing side lengths. Now, notice how I underlined sides. I've even heard a lot of you say, oh, well, we can use the Pythagorean theorem to find angles. Not true. Pythagorean theorem is simply finding side lengths of a triangle, a right triangle. You cannot use the Pythagorean theorem to find angles. Does that make sense, everybody? Very important that we don't ever try to do that. We're going to learn how to find angles and stuff. That's what right triangle trig is. But a lot of people, they think, oh, I know the Pythagorean theorem. That works for anything in a right triangle, but it's not. It's only to find side lengths. So do you see how I scarred the sides? Okay. All right. So I'm going to have you look at these, and you tell me if we can truly use the Pythagorean theorem. Because I don't want you guys next year to go start taking an ACT, and they will put a triangle on there that you have to find missing lengths. And they will make sure it's not a right triangle, due to the fact that people use the right triangle Pythagorean theorem when they can't. Luckily, you'll have learned it from secondary 3 next year, hopefully before you take the ACT. All right, so can we use the Pythagorean theorem in this one? Is it the right? To find question mark. No, right? That would be using the Pythagorean theorem to find an angle. Does everybody understand why we can't use the Pythagorean theorem here? We can't use it to find an angle. All right, can we use the Pythagorean theorem here? Yes or no?
Yes.
Yes? Good. No, we don't know for sure that it's a right triangle. We weren't given that that's a right angle, so we would not assume that we could. Even though it looked right, we wouldn't assume. Now, in the wording, though, if I said to you, this is a right triangle, then you would be able to. Does that make sense? So right now, though, just from the picture, we couldn't use the Pythagorean theorem. All right, what about this one? Yes, we could. We're finding a missing side length. It's a right triangle, so we could use the Pythagorean theorem. Now, right here, could I use the Pythagorean theorem to find that angle? Could I?
No.
No, Pythagorean theorem is not finding angles. Do you all understand? Yeah? We're all good. Okay. Awesome. All right, so here is the Pythagorean theorem, guys. So it's given a right triangle with side A and side B with a hypotenuse of C. This is the Pythagorean theorem. A squared plus B squared is equal to C squared. Now, here's the very most important thing. Really, A and B don't matter at all. It doesn't matter where they go. But the most important thing is that our C squared is across from the hypotenuse. It's across from the 90 degrees. It's our hypotenuse. So everybody, this is important. So C must be across from the 90-degree angles. That must be our hypotenuse. That's the only important thing. The other two orders don't matter. So now, I don't even use the Pythagorean theorem written like this. A squared plus B squared is equal to C squared. This is how I'm going to say it, because A squared plus B squared is equal to C squared starts to throw students off. They're like, well, what side's ABC? And they get too caught up in the ABC part, okay? So this will really help you if you think of instead of the Pythagorean theorem like this. Really, what we're doing with the Pythagorean theorem is we're taking side 1 squared plus the other side squared, so plus side 2 squared, and that's equal to the hypotenuse squared. Now, once again, hypotenuse is across from the 90-degree angle. So that's the huge important part. We could have done side 2 squared plus side 1 squared, but the hypotenuse squared must be after the equal sign. It's all over there. Does that make sense, everybody? Yes or no? All right, so I'll let you get that down, and then we'll just start practicing. Honestly, we'll just start practicing. And we'll use what we learned yesterday as well in a little while. So, all right. one together. All my examples are going to come from your worksheet, so I'm fine with you working off of that. So it says, do the following lengths form a right triangle. So we're given this triangle. We don't know if it's a right triangle. We have no idea. But we do know, so this is something very valid that you might see on an end-of-level test. Now, they might say, looking at this triangle, is it a right triangle? You have to know, okay, well, I'm looking at the sides, right? I'm looking at sides. So sides of right triangles means the Pythagorean Theorem. So if the Pythagorean Theorem works, then it's definitely a right triangle, right? If the Pythagorean Theorem works, it's a right triangle, because right triangles, the Pythagorean Theorem will hold true. So what we're going to be doing is checking the Pythagorean Theorem, which is side 1 squared plus side 2 squared is equal to the hypotenuse squared, right? So let's plug that in. See, side 1 squared. Well, first of all, which one of these? We have no idea. This could be the 90-degree angle. This could. Which one do you think is the hypotenuse? Which length? 9. Good. The hypotenuse technically is the longest side, right? Hypotenuse will be the longest side. So look for the longest length. That would be 9. That must be the hypotenuse. Does everybody understand that? The longest side will be the hypotenuse, which is the across from the 90 degrees. Okay, so if this is a right triangle, then side 1 squared, which is 6 or 8, it doesn't matter, so I'm going to do 6 squared. So 6 squared plus side 2 squared, which I'm going to go with 8. Why not? But we have to go with 8 if we went with 6 first. So 6 squared plus 8 squared must be equal to 9 squared. Now, if this is a right triangle, this is a true statement. Does everybody understand that? If this is a right triangle, this is a true statement. The Pythagorean Theorem will hold true. So now you'll take your little calculator. You'll do 6 squared. I'm going to show my work. 6 squared is 36. So you have 36 plus 64. 8 squared, 64. That better be equal to 81. 9 squared is 81. 36 plus 64 is 100. So we have 100 is equal to 81. Is that a true statement? Not a true statement. Okay, so that is not true. So this must not be a right triangle. Otherwise, the Pythagorean Theorem would have worked. So this is not a right triangle. So we're kind of proving that it's not, using the Pythagorean Theorem. Does that make sense? Everybody's good. Okay. Okay, so then I'm going to do number 5, and then I'm going to let you work. So look at number 5. So we're given that A is equal to 6.4, B is equal to 12, and C is equal to 12.2. All right, so the first thing we've got to do is we don't even need to draw the triangle out. We can just look at them and think about it. So I'm going to ask you, okay, so we're asked, do the following lengths form a right triangle? Well, if they do form a right triangle, then the Pythagorean Theorem will hold true. So we know the Pythagorean Theorem is side 1 squared plus side 2 squared is equal to the hypotenuse squared. So out of these lengths, guys, out of A, B, and C, which one must be the hypotenuse? C. Good, C, right? But that's because, not because of C, right? Because I could have used C. F, B, D, right? But it's because that's the largest length, right, everybody? Okay, so that must be our hypotenuse. The other two sides don't matter. Order doesn't matter. So I'm just going to go with 6.4 squared plus 12 squared better equal 12.2 squared. That has to be the hypotenuse squared. So then you'll take your calculator and verify that. So you can do 6.4 squared. You all know how to type it into your calculator. You're all practicing. 6.4 squared plus 12 squared. That is, over here on the left, I just combined those all in one using my calculator. That's 184.96. That better equal 12.2 squared. So 12.2 squared, and you get 148.84. Did it make a true statement? No, that is not true. So this must not have been a right triangle. These lengths did not form a right triangle. So this one is not right. Still a triangle, but it's not a right triangle. If it was, the side lengths Pythagorean Theorem would match up. Does everybody understand how to do this? Okay, so now I'm going to have you give you time to practice 1 through 6. Show your work. Ready, set, go. So we really are staying pretty basic. Like I said, though, you have learned this in the past. So now we're going to go through and we're going to find missing links, and we're going to round to the nearest 10. Now I'm asking you, though, a couple things to notice here. We learned yesterday how to break down radicals, right? We're going to be using that again today. So let's look at number 7. First of all, here's a good rule of thumb for you. And this is really a rule of thumb you'll use on an end-of-level test, on your ACT, whatever. So look at the original triangle here. Look, we have side lengths 4 and 8. Do we have decimals? No. So a decimal answer would not be considered acceptable. Does everybody understand? If you were given decimals in the original triangle, you would give a decimal answer because that's what you originally started with. So that's a rule of thumb we're going to use through this whole unit. So looking at this one, okay, our final answer, we won't do the decimal answer, but we just start out this normally. Here we go. So first of all, we're going to find missing links. This one, we're missing this. I'm going to call it question mark. We're missing that, right? Okay, now this is a right triangle, so we know if we have 2 links of a right triangle, we can use the Pythagorean Theorem to solve. So our Pythagorean Theorem is this. Side 1 squared plus side 2 squared is equal to the hypotenuse squared. So in this problem in particular, are we finding a side or a hypotenuse? Good, we're finding the hypotenuse. Very good. So right here, that's what we're going to be finding. Okay, so side 1 squared, I'm going to go with 4 squared. It doesn't matter though, we could do 8 squared first. 4 squared plus the other side is 8. So 4 squared plus 8 squared equal to, I'm calling it question mark, so question mark squared. Does that make sense, everybody? Yeah. Now we'll just solve. I'm going to show my work. So we have 16. 4 squared is 16. 8 squared is 64. So that's equal to question mark squared. So then you'll add those up and you will get 80. So you have 80 is equal to question mark squared. Now it's smart. Why not check to see if it's a perfect root? So now, we haven't solved for question mark quite yet. We have question mark squared. We want question mark alone. How do we get rid of the square? Square root. Good. Square root both sides of the equation. Then our root cancels out with our power, leaving us just with a question mark. So what we have is question mark is equal to the square root of 80. Now from there, take your calculator, see if it comes out even. The square root of 80, it's a decimal. And then you say to yourself, the decimal answer is not acceptable. It's truly not. On an ACT, they will not do that. So then you have to look at your square root and say, does that simplify further? Yes. So I'm off to the side here. I'm going to break down. I'm writing it so I have more room. I'm going to break down 80 into its factors. This is what we learned yesterday, right? So I'm going to go with 8 times 10. 8 breaks down into 4 times 2. 4 breaks down into 2 times 2. 10 breaks down into 5 times. Okay, good. Now we're down to our prime factors, right? Now we're pulling out groups of 2 because this is a square root. If there's 2 of them, no matter where they are, they can leave the house. But don't double dip. 4's not there, 8's not there, 10's not there. We broke them down and rewrote them as these factors. Okay, pulling out groups of 2. There's 2 2's right there, right? Then there's 2 2's right there. And then left underneath is a 5. So remember though, don't make the error of pulling out a 4 for these 2 2's. You're taking the square root of 4 here, which is 2. Or just think of it like this. Because there's 2 2's, you can pull out a 2 accounting for those 2 2's. So we're going to pull out a 2 for those 2 2's. We're going to pull out a 2 for those 2 2's, right? And then left underneath was a 5, so left under the root was a 5. Then we multiply anything that's on the outside together, anything that's left underneath together. So 4 square roots of 5. That is our hypotenuse. It's equal to 4 square roots of 5. Okay? Any questions on that? Okay. Awesome. All right, number 10. Let's go through number 10 together. So we have this right triangle. We're asked to find the missing side. So once again, we're finding question mark. we're finding the hypotenuse again, right? So we're going to be doing 3 squared plus 7 squared equal to question mark squared. Hypotenuse has to be on the other side of the equal sign, right? So then you can add them up. You can do 3 squared, so we have 9 plus 49. 7 squared is 49. So we have question mark squared. So what we have is 58. 58 is equal to question mark squared. Well, that's not question mark. We need to get question mark completely alone. So we are going to take the square root of both sides of the equation. Then our root cancels out with our power, leaving us with question mark. So we have question marks equal to the square root of 58. Now, did our triangle start with decimals? No. So we cannot use decimals. So we've got to break this down by hand if it does. So square root of 58. Breaking it down if it does break down. So you just take your calculator. Let's say you have no idea. So 58, try dividing it by 2. 2 and 29. It did go into it. 2 and 29. All right. Does 2 break down further? No. 29. Can you think of any factors of 29? There's not any. So we can't pull out of 2. We can't pull out of 29, right? So they're left underneath. So you multiply them back together, and we're back to the square root of 58. Right? So our answer is just the square root of 58. So we couldn't simplify, so that's our answer. Believe it or not, though, this is considered more simplified than the decimal answer. It truly is. This is an exact answer. Okay? So that's what's expected of you on the ones that do not have decimals. Now, I'm going to do 7 through 12. Ready, set, go. Looking at number 15, does your triangle start with decimals? So you're okay to do decimals in this one. So once again, rule of thumb, if it does start with decimals, if that triangle originally had decimals, then decimals are fine as an answer. So looking at this one, we're trying to find this one. Now be careful, the reason I'm doing this one is because it's different. So remember that since this is a right triangle, and if you're given 2 lengths, you can find the third length. And the Pythagorean Theorem is side 1 squared plus side 2 squared is equal to the hypotenuse squared. Alright, in this one, we were given the hypotenuse, right? Across from the 90 degrees. Does everybody see how that's the hypotenuse? Okay, so we've got to be really careful when setting this one up. So we're going to do side 1 squared. Well, I'm going to call that question mark because that is one of the sides. So question mark squared plus side 2 squared, that would be 3.6 squared. So 3.6 squared is equal to the hypotenuse squared. So 7.4 squared. Does everybody see how I set it up? This is really important. You can't just do this. A lot of people, they come from secondary math 1 and they think they can just do the Pythagorean theorem and always put whatever they're missing on the other side. That's not true. Does everybody understand how 7.4 must go on the right side of the equation? It's our hypotenuse. That's the formula. Is everybody good with that? Okay, so now we'll piece by piece solve for question mark. So we have question mark squared plus... So, and you know what I'm going to do actually is I'm going to just leave it right now as decimals. I'm just going to go like this. Okay. Hopefully your guys' brains are advanced enough to think about this. So we're trying to solve for question mark, right? Because I don't want to write down the huge long decimal. That's the reason I'm doing this. Okay, so to get question mark alone, are we going to subtract 3.6 squared from both sides of the equation? Won't that add up to be 0? Okay, so we're going to have this add up to be 0, which is what we want. So we have question mark squared is equal to, now on the right, we have 7.4 squared, and now we have minus 3.6 squared. Does everybody see what I did? So then, I'm going to actually calculate that. I'm going to do in my calculator 7.4 squared minus 3.6 squared, and you get 41.8. So we have question mark squared equal to 41.8. And question mark is not alone. Now what will we do? Good, square root both sides of the equation. And the good news is the root cancels out the power. So we have question mark is equal to, and we can do it in our calculator because we started with decimals, we get to end with decimals. and you get 6 point, let's round to 1. This was rounded to 1 decimal place, so our final answer would be appropriate for it to match. So we'll round to 1 decimal place, 6.5. So question mark is equal to 6.5. Does everybody understand that? Okay. All right, let's do one more together. Number 19, I'll do. Okay? Last one, then I'm going to let you just work. So we have 5.2 squared, we have 9.2 squared, and we're finding this side. It is the hypotenuse in this one, right? So side 1 squared would be 5.2 squared plus 9.2 squared would equal question mark squared. Now, question mark squared is the hypotenuse, so it must go on the right side of the equation. First is, remember on the other one, we have to be careful because we were given the hypotenuse and not one of the sides. So everybody be really careful as you go through this. All right, so then we can just solve. So I'm going to just take my calculator, 5.2 squared plus 9.2 squared, and I get 111.68. That's equal to question mark squared. And then from there, to get question mark alone, we square root both sides so that our root cancels out the power. So then you do the square root of 111.68, and you get 10 point, a huge decimal. They started with 1 decimal place, so we'll do the same. So 10.6. Okay, so as you go through, be very careful. Just be really careful. If you're given the hypotenuse, make sure you plug it in on the right side of the equation. You should be plugging it in right there if you're given the hypotenuse across from the 90 degrees. And then algebraically solve for question mark otherwise. All right, so now you'll finish the worksheet. As you go through them, check with me. After you've done a few, check with me. Ready, set, go.